Hello and welcome to Tech Simplified TV and a very warm welcome to the Semiconductor Podcast. We are back with another exciting episode and today our guest is Mr. Shitendra Bhattacharya from Bangalore. He, he is Regional Director of Emerson's Test and Measurement Business Group. Uh, you must be know that NI, National Instruments, who are famous for test and measurement software and hardware, that has been acquired by Emerson. And Mr. Bhattacharya is linked with NI for last 17 years. He has a proven track record and leadership experience. So we will talk about a very important segment with him, that is test and measurement devices, their impact, and what is going on right now there. So welcome, sir. Welcome to Tech Simplified TV and TSP. Thank you for accepting our invitation.
Thank you, and thank you for having me on the podcast.
Sir, you have, as I have came to know that you have completed your graduation in BTech in a chemical sector and then moved to instrumentation and connected to NI for last 17 years. So mostly electronics, electrical and instrumentation people goes to this side. How this journey happened? Share with us your journey.
Yeah, sure. Actually, interesting you asked me this of me having done my chemical engineering and then moved into this field. And that's actually very synonymous to what NI actually stands for, because the core philosophy around which NI was built is to simplify the life of engineers and scientists and to really allow for engineers, irrespective of which domain they are in, to be able to test, validate, or do prototyping of any products. And programming should not become a bottleneck for you, right? So 17 years, yes, it's been quite a ride. And I started when NI was still gaining ground in India. I've seen it evolve from being a niche player into a strategic technology partner across various industries. Over the years, I've had the opportunity to work with very passionate engineers, drive key account strategies, be part of major expansions, and also including growing our local presence and influencing some of the key verticals like defense and semiconductors. I think one of the standout milestone uh, for me in this whole career was really helping establish an NI India's strategy focused on more of the local engineering market, which really shifted the needle for us. And I think that feeling of building something so meaningful from the ground up is what has really kept me going. And like I said in the beginning, I think the shift from chemical engineering to focus on the electronics industry is very synonymous to how NI also helps engineers and scientists seamlessly transition from one domain to the other.
Okay. Actually, then your philosophy of your career has completely aligned with the philosophy of the company you are working for.
Yes, absolutely.
And since you said that you when you joined NI was just gaining its foothold strong in this country uh, and making mark. So, what are the key differences in market dynamics between India and other countries you have seen?
Well, yeah. So India, I think, is a very different beast. While developed markets are more structured and mature in terms of all their processes and test maturity, I think India is still in a phase of accelerated growth, very hungry, very agile, and also often sometimes a little constrained, I would think. So, for example, like the purchasing behavior in India leans more towards like a value-centric decision making, but innovation is always at the core of it. And the customers in India are always solving cutting-edge problems. I mean, that being said, I'm not saying that the other countries don't have cutting-edge problems to solve, but they often have to do more with less. I mean, in India, we have to do a lot more with a lot of less resources, right? And that's where, even from an NI's perspective, the flexibility really shines. We don't just sell tools, we co-create solutions with the customers, that allows for us to serve a market like India, where they really need solutions to problems more faster and more easily at lower costs.
Okay. So, are you working closely with Government of India and has seen what's the response from Government of India in and academia in embracing test and measurement solutions and innovations?
Hmm. So I think over time, I have seen a significant shift in the mindset, and all for good reasons, and especially more so I think in the past 5 years. So programs like Make in India and the India Semiconductor Mission, the production linked incentive, design linked incentive. I think these initiatives have really opened up doors to more innovation and more so on test innovation. And also academia is a very key part of this. I think if you take the core center view of innovation as that lens, you triage education, research, and industry together, right? And so then academia plays a very key role. So academia is also stepping up with more institutions investing in modern labs, research infrastructure. There's still a long way to go in bridging that gap between theory and application, but the intent is very strong right now, and I think we are actively collaborating to accelerate that journey.
Okay. Where do you see the biggest growth opportunities in India, engineering services and R&D sector?
So there are plenty. India's engineering services ecosystem is transforming significantly and very, very rapidly from being a cost hub to an innovation hub. Back in the day, India was only considered to provide low cost services. You would have a lot of back office operations and continue to be like a best. I mean, it was always considered to be a best cost geo, right? Even today, we have the cost advantage. I wouldn't say so that we don't, but at the same time, I think what's also happened is India has now become the core of innovation. So it's more of an innovation hub now than just being only a cost hub. So the biggest growth I think will come from product engineering, systems validation, and turnkey design services. And companies want partners who can really own outcomes, not just execute on tasks. So that's where even at NI we see ourselves playing a very key role, where we are able to help bring in IP driven software centric test
Hmm.
strategies that is able to reduce the time to market and improve the product reliability.
Okay. And new government is very pro right now, very much interested in encouraging this with India Semiconductor Mission and chip to startup. All of these things are happening. So, what you think in coming decade, 5 to 10 years, where we are heading towards? What is our destination? Where we are going?
Is this a reference to which industry in specific or in general is your question?
Yeah, in general, electronics, because test and measurement in electronics, it's a
Okay.
very important part of electronics industry. So you are dealing with that. So that's why I'm asking.
Okay. So, well, I think the semiconductor mission has picked up a lot of steam over the
Hmm.
last 2 3 years. So that's a very exciting domain, and the intention of being self-reliant allows us to also begin to think. When you're actually pushed to the wall is when innovation happens quite a bit, and when you want to start thinking about Atmanirbhar Bharat and being self-reliant, I think the core of electronics and intelligence today lies at semiconductor layers. So India's semiconductor journey is just beginning, but the I think ambition is really massive, and with fabs in the pipeline and policy ecosystem that supports local manufacturing, I think we'll see exponential growth in chip design, validation, and packaging. What excites me is not just the manufacturing part, but how this will stimulate a whole new generation of test engineers, tool makers, and local innovation in test automation. I think what we are seeing evolve is it's a complete ecosystem play, and companies like us are very well positioned to contribute. And there are many such companies today in the industry which really thrive on an ecosystem play, and that's what is the exciting part. It's not just about the core fab or OSAT, but every other company that contributes
Hmm.
to the entire value chain that has to evolve and develop, right? And that's a massive opportunity for everybody. So the next decade is really, I mean, I think as many reports have already highlighted and said, the next decade really belongs to India, and this is why it is, because the entire ecosystem is what is going to evolve.
And how has NI's technology offering has evolved with the time to meet industry need? If you give us some example.
So, yeah, I mean, from just providing hardware to complete software connected platforms, I think that's really been the shift for us. Our focus today is to provide platform centric modular hardware with an open software and integration ready architecture, right? So, we have also tried to stay abreast with the latest technology, and that's been one of our unique propositions, that we have always been at the forefront of innovation, especially in the test and measurement world, right? So we were
Yes.
the first to introduce the cloud connectivity to our test measurement equipment, machine learning ready workflows, better interoperability with all other softwares like Python and third party tools. So the idea is very simple. Keep the philosophy as we just want to reduce complexity, increase reuse, and scale across the entire product life cycle. And that's how our offering continues to evolve to meet the industry need.
Okay. So there are some emerging areas like 5G, EV, aerospace, obviously semiconductor. So in all this sector, what is the test and measurement? What is its role? What kind of role it's play in all these emerging and evolving sectors?
Right. So I think test isn't just a quality gate anymore. It's part of product design. In 5G, for example, it's about validating millimeter wave signals, right? In EVs, it's about battery characterization, powertrain validation, or the battery management system testing. In aerospace and defense, test ensures mission critical systems perform reliably under the variety of extreme conditions that it goes through. So our job at NI is to make sure these companies can test much more faster, smarter, and with confidence in the results, no matter the application. The confidence in the results that you are able to obtain through all the test scenarios that you make your product go through is what matters the most. And doesn't matter what the application is. So irrespective of any emerging area, whether it be 5G, EV, semiconductor, defense, right, whatever it might be, we ensure that test becomes your strategic differentiator, right? So that's no longer just a quality gate.
Okay. So is there any go-to-market approach for NI? I mean, for latest growing these sectors, any go-to-market approach do you have?
Absolutely. I think we are not just selling to large OEMs. We are working with startups,
Mm-hmm.
mid-tier innovators who are driving, breakthroughs in, let's say, for example, radars or chip design, propulsion systems. So our go-to-market approach includes strategic alliances and deep technical mentoring. So collaborate with incubators and defense accelerators so that they can get ahead of the curve. We run a exciting program called the Technology Accelerator Program, or called Planet Nurturing Innovation. What that actually allows us to do is it provides easy access to NI's cutting edge technology to early stage startups who want to come and prototype or validate their algorithm or their product, because it's not always easy to get access to such technology, but we
Mm-hmm.
enable for it. So we have an engineering innovation center in India that allows for these companies to come in. And like I said, we also collaborate with incubators and defense accelerators so they can get access to these technologies much easily, conveniently through these channels. So yeah, all through and through OEMs, we are working with startups and the mid-tier innovators.
So in the whole process, you are there. I mean, always technology partner basically. Technology partner doing hand handling for some startups. That is also true, as much I understand, isn't it?
That's absolutely. We are always wanting to be the technology partner for organizations who are innovating and are making breakthroughs through product development, and that's really where we want to be.
Okay, so your approach is basically very collaborative. So, what
Yes.
are the key takeaways from engaging with India's aerospace defense and research body?
Hmm. And this is like been one of the oldest industries also, aerospace and defense. I think the top two things that really stand out for me is ambition and accountability. I think these institutions are deeply committed to innovation and self-reliance. At the same time, they demand a lot of robust standards which are compliant, a lot of future-proof test systems. And I think what we have learned is that flexibility, speed of support, the ability to co-develop solutions are non-negotiable. So it's not about selling just a system. It's about really being a strategic partner with them in all their long-term missions. And I think that's really been the key takeaway from working with these organizations for a long period.
Okay. So, I have just a query. I mean, a little bit curiosity that recently I have, in fact, seen in some videos in YouTube that some defense startups are also there. So, is it a new trend or it has been there 15, 10 years ago? Also, these startups were there. I mean, private involvement, private company involvement in defense in this country. Oh, is it a new phenomenon?
I won't say it's new. I mean, it has always existed,
Okay.
but it's definitely ramped up quite a lot right now, and
Oh,
more so because of the support from the government.
no.
The intent for the government to do as many things more local. The whole Make in India or Atmanirbhar Bharat initiatives has encouraged a lot of companies to actually build technology locally within the country, right? So we do want to reduce our dependency on importing some of the key critical technologies, right? So that is an opportunity. I mean, when you take a look at the kind of defense infrastructure that we need as a country, being such a large nation, there's lots of opportunities for various companies to build, whether it be mechanical systems, electronic systems, the intelligence that goes into some of the defense technology. So the opportunity is a lot. So that's where I think the total number of defense startups is a lot more today. The
Okay.
other thing is also the openness from the government to actually allow for the ease of participation of the private companies. They have made the processes a lot more inclusive, I would say. So that is also allowed for because back in the day you would find companies being very reluctant to work on government contracts because maybe you don't get your payments on time, or the projects just take very long to complete. I think that has changed, and that has made it more
Okay.
exciting for companies.
In fact, as much as a common person, I'm not a expert in defense things. So, still, I believe if it's everything is happening here, then strategically and financially, that is actually good for us as a
Yes,
country.
that's, yeah, that's right.
So, so, what advice and direction would you give to young engineers who are aspiring to enter this field of test and measurement space?
Yeah, I think the generation has evolved quite a bit. So I'm not very sure of the advice that I give will actually be relevant, but I still feel it holds good. I think I would say stay curious and don't shy away from all the boring bits, and learn the full product life cycle from concept to validation. I think test and measurement may not always look exciting on the outside, but it's really where real engineering meets real world problems. So learning tools like LabVIEW, Python, TestStand, I think that's something that I would love to see the young engineers who are aspiring to actually have all of these capabilities, build stuff, fail fast, and above all, just keep asking why at every stage of test. I think that's where innovation lies.
I mean, NIS has automated test system. So, how it actually help in speeding up this validation and characterization in semiconductor?
So, semiconductor validation is quite data heavy, very time bound, and it's a iteration driven process. So, NI is automated test systems, which is generally powered by PXI, which stands for PCI extension for instrumentation, test and measurement abstraction layers that we use. That actually helps reduce all the cycle times drastically. So what you can end up doing is you can run a lot of parallel tests, automate data logging, and even integrate all the AI ML models to detect anomalies very early. So it's about shifting from being reactive to doing predictive testing, and that's really a game changer for fabless and IDM players alike.
Okay. So, what are the challenges you face and address in wafer level testing and final test of ICs?
Yeah. So wafer level testing and final test, I think, have become very complex, I would say, especially with the rise of heterogeneous integration and advanced
Hmm.
packaging. So the challenge is really balancing the throughput, the cost, and the coverage, right? So at NI, we try and address this with high-speed data acquisition, with flexible test sequencing, and tight synchronization across multiple instruments. So our modular architecture really means test setups can scale with device complexity without needing to rebuild from scratch each time. So it's really about giving engineering teams the ability to move fast without compromising on accuracy or test economics.
So previously, I mean, when it was not heterogeneous, older nodes, the validation, this procedure is equally critical or complex or less complex.
I mean, it was always complex, but the complexity never reduces, right? With
Okay.
heterogeneous integration and advanced packaging, the number of test nodes have also gone up. So you have to now, do multiple high speed tests, and the test sequencing needs to keep
Hmm.
changing continuously and evolving.
Hmm.
So that is the criticality, and that's the complexity, I would say, that is actually coming now. You should be
And
able to do that. So that is not something that was easily possible with tools that were available in the
hmm,
past.
hmm. And input stimulus which is given for testing, that is also now require different types of inputs because it's the heterogeneous. I mean, in chiplet case there are multiple modules and used, so set of stimulus also, different types of stimulus getting need to provide for testing. Is
Yes,
my
that's right. Absolutely. No, you're right. So
I'm not testing background, I'm trying to connecting the dots because from my background actually, that's why I'm asking these questions.
no, you're right. Absolutely. I mean, the input stimulus also has to keep changing. I think, again, like I said, the applications have become so many and so wide.
Hmm, hmm,
Depending
hmm,
on what you're designing for, you will have to test your, at the wafer level, and the final test of the ICs also have to keep evolving. And that's
hmm,
why the stimulus input, you have to provide the right level with the right power levels. All of that has to be taken care of. So I think that's exactly what I was trying to say, that complexity has gone up with the rise of the heterogeneous
hmm,
integration, and the
hmm, hmm,
packaging level become advanced, they become smaller and compact. So the accessibility to the test points are not as easy, and the speeds have also gone up, right? So that's
Hmm.
also the additional complexity that gets added in. And so instruments in the past were not able to handle all of these as well, but it had to evolve. And
Hmm.
both the industries feed into each other, right? So think about it. When you're testing a chip, your test equipment, or for that matter any equipment, your test equipment needs to be couple of orders better than the device under test itself, right? Then
Hmm.
that's able to test. And then when you're actually designing these test equipments, you are actually using some of these chips back into your test equipment itself, right? Because the test equipment is also based on these capabilities of the chips that you use. So
Hmm.
the industries feed into each other. The complexities also keep interchanging, and so that's how you have to keep evolving. So that's the exciting part about this industry, and that's how we are able to also address some of these things with our high speed data acquisition, flexible test sequencing, and tight synchronization.
Okay. I just want to mention a beautiful coincidence because in Tech Simplified TV we do technical videos we made, and right now I'm working on a IC testing. I'm making video on a topic: IC testing, failure testing, fault models. So this is
Okay.
the third episode. I was just yesterday completed the recording of it, and
Oh,
today I'm interviewing you. It's quite timeline has been I mean, quite. It became a nice coincidence for me actually.
okay. Okay,
So
that's good. Good. I would love to see what you've recorded as well.
okay, sure.
Yeah.
So how does NI ensure test coverage for mixed signal and RFICs, especially in automotive and 5G sectors?
Again, mixed signal and RFICs are also, in their own right, quite complex. So it's really where analog precision meets digital complexity. I think all under harsh performance and compliance requirements. For automotive and 5G, for example, right? I think timing, jitter, and RF performance are everything, right? So, and I solve this with wideband RF instruments. We provide tight software integration and also advanced triggering capabilities. Plus, we bring in software-defined measurement systems that really allow users to define, refine, and also reuse some of the test logic. So, coverage evolves as the silicon does. And in these verticals, agility really matters as much as the spec compliance. And so that's how we are able to ensure the test coverage.
Yeah. And AI and ML has already been integrated in your softwares and tools, their performance, just to enhance their performance, as you mentioned already.
Yeah, yeah, that's right. Yes,
So LabVIEW is one of your flagship platform. I mean,
right.
it's very famous. Whenever
Yes,
we search in internet, first come in first two three result, it's about LabVIEW.
yeah,
So how does it evolve to support modern semiconductor test challenges?
yeah. Actually, LabVIEW was one of the first graphical programming languages, and LabVIEW was made to really help engineers and scientists program. So essentially, you did not want somebody to be caught on to not knowing, syntaxes and codes. And it was so graphical and intuitive that just like how you draw a flow chart, you can actually build a LabVIEW program. So it was that simple. And I think
Okay.
every engineer knew how to, make a flow chart. So I think LabVIEW has grown from being a graphical programming tool into a full-blown engineering integration platform today. I think today LabVIEW supports Python. It integrates with Git. It connects to all the cloud platforms. It runs on real-time operating system targets. So for semiconductor test in specific, it enables rapid prototyping of the test IP. It allows for easy control of all the mixed instruments and very seamless integration with external data analytics tools. So it's still the simple drag and drop mechanism. I think the fundamentals of LabVIEW have not changed, but now with the power to orchestrate complex test sequences at this same scale the semiconductor industry demands. I think that is the beauty of how LabVIEW has evolved as well. And now we've also, like I mentioned earlier, integrated AI ML capabilities into the software. So that makes programming a lot more simpler, a lot more intuitive, and much more easier for engineers and scientists, giving them more time to actually focus on the core product development than actually figuring out how to test the product.
Okay. So, how NI's TXI based modular instrument contribute to scalable semiconductor testing?
So PXI is really at the heart of everything we do in semicon testing. It's the, if I can say, think of it like the Swiss Army knife of instrumentation, right? Swiss Army knives have like multiple different tools. The same thing with the PXI. And the biggest advantage I will say is its scalability and ability to synchronize between multiple instruments.
Okay.
With PXI, you can really start with a very small benchtop setup and you can scale it up to be a full rack for production. So it supports high speed digital, precision analog, RF, and power all in one single chassis, right? And you can get sub nanosecond levels of synchronization with reduced footprint and much easy reconfiguration. So you can add in modules depending on the kind of capabilities you want to have at any point in time. So that allows you to easily reconfigure your system. So I would say, like in a world where chips evolve almost every 6 months, I think PXI ensures your test bench can keep up without any forklift upgrade that you would need for your testing.
There is a generation. I mean, for any chip also, it with generation some things changed, and when you sell a product to a customer and some new version, software version get upgraded and all, so that kind, like other EDA vendors, they provide support. This kind of support system is also there for NI, obviously, isn't it?
Yeah,
I
yeah,
mean, that
absolutely. I
time
mean,
also.
yeah, yeah.
uh,
We launch a version of our software every year. There is upgrades that are
okay.
always done every year, and our customers can easily get access to that upgrades, and to stay abreast with all the new capabilities. And we also ensure there's enough backward and forward compatibility of our software. So,
Hmm.
absolutely, as when there is an evolution, we would provide that to our customers in the easiest possible way.
And this is first time I am talking to someone who is from this sector in electronics. So I have, I had curiosity, so I'm just asking because I have a little bit knowledge about how cadence tools and synopsis tool that work, because sometimes I have used it. I have for a very little time I have worked in synopsis, so I have at least an idea. I don't have any idea about test and measurement tools. Whatever knowledge, that's completely theoretical. So it's really enlightening for me to talk to you in this session.
Okay,
Whatever
that's
I
good.
have learned, that also I'm from you. Many more information I'm getting. So, what kind of
Okay.
resources, kits, and programs does NI offer to universities for hands-on semiconductor education?
So, I mean, for us, we have always believed that real innovation starts in the classroom. So that's why we have built a lot of university focused programs.
Mhm.
And we have technology and platforms also that help universities actually, learn through an experiential learning process and a mechanism, right? So we have products like the Analog Discovery Studio, which is a platform which helps, like for example, you can build a custom semiconductor teaching lab, and you can have a curriculum which is aligned with semiconductor teaching and allows for the students to do practical experiments on these platforms, right? So we also offer LabVIEW based training, and we also help with a lot of sponsored research initiatives, especially in the university level. So it's not just the hardware. I think students get access to industry standard tools and real world application projects very early.
Mhm.
And I think that skill gap that exists today, there are annually about 1.5 million engineers that graduate today, as of today. Only 50% of them meet the employability standards, right? But what is also exciting to see is that the uh, compounded growth rate of students who are opting for the STEM AI ML courses is growing at 15%. Right? So means that
Mm.
people are interested. They see an opportunity. They see that there is uh, engineering is the way to solve the grand challenges of the world, right?
Mm.
And so hence people want to learn these different concepts and fundamentals to become a better engineer. And so that's how we have also built some of our platforms to allow for engineers to be able to learn through an experiential way, where they understand the fundamentals not just on theory, on paper, pen, or on a board, but actually go ahead and implement certain experiments which teaches them the concept. And then it also takes them seamlessly to real industry world problems. So you can actually learn how to solve industry challenges very early in your engineering thing. And then we also take it down even to high school level, right? So we even teach some concepts at a high school level, so that it starts triggering the young minds to think about STEM.
Okay. I mean, any CBSE or ICSE board school or any school? I mean,
I
what
mean,
is the way you collaborate?
these are not necessarily part of the curriculum in the high school, but these are
Mhm.
always like add-on additional coursework that kids like to do. So we would set up a small workshop or a hands-on session for kids just to come and play around, take a look at what some of the technology looks like, explain some
Okay.
of the big concepts like they learn in physics in school, so that they have some fundamental excitement towards engineering.
So, if a school wants, how can it collaborate with you regarding all this?
I mean, they can reach out to us. We have programs that allow to work with schools. So we
Okay.
have our teams who take care of that. So just reach out to us and we'll support them.
And, same for universities also. Because in
You
DLI also many university engineering colleges, they are especially NITs, they are included in DLI scheme and chip to startup program, and they are getting tools from in subsidized rate the chip to under chip to startup program. In West Bengal also they have get this they got these tools.
So we
That's why.
run a full-fledged university program.
Okay.
So have a very, very strong, robust university network. We've been supporting the universities with labs and tools and access to industry problems for many years now, from actually the time we've been in India. And whether it be IITs, NITs, any other universities as well, right? So that program is fairly strong at NI. And we also provide curriculum-based learning modules. So, LabVIEW can become part of the curriculum. So we've worked with multiple board of studies to ensure that LabVIEW is part of the curriculum in many universities.
Okay. So do all these solutions provided by NI that can be integrated with EDA tools, standard EDA tools like if I give example like Cadence tool or Synopsys or Menta Siemens can be integrated with their tool.
Absolutely. We
Okay.
are working more closely than ever with all the EDA tool chains. I think the goal is really to close the loop between simulation and the silicon, for example, right? So we support integration with EDA outputs, bringing test vectors, stimulus response data, and debug hooks that are there into validation environments. So that basically means that what you simulate in pre-silicon, for example, I'm just talking on the
Mm-hmm.
semiconductor side. So if you simulate in pre-silicon, the what you simulate in pre-silicon can be tested and debugged in the same language post-silicon, right?
Okay.
So it's a smoother handoff, faster debug, and a shorter path to silicon confidence.
Okay. So, the kind of work it's engineers do in NI, if any student, which stream can join? Electronics, electronics and communication, that is ECE, and computer science. What streams of students from they can join NI if they
To
want to?
join, I mean, I think we don't really differentiate uh, too much on the engineering background. I think what we
Okay.
look for is just a good engineer. I think the fundamentals that we look for is an engineer who has the solution mindset or the ability to solve for problems, right? So whether you be a chemical engineer like me, right, or you can be an electronics and communication engineer, a biotech engineer, if you have the mindset to be able to solve problems
So,
and you have the solution mindset, you can definitely opt for opportunities within an eye. So, of course, if you're getting into some of the core development activities which need very specialized skills, then yes, we would look for very specialized skill set, and that would mean then a special course that they have done or a degree that they've obtained. But otherwise, in general, we look at solving customer challenges which are generally engineering problems, and these are some of the grand challenges in the world. So anybody with a solution mindset and a problem solving ability could be a part of NI.
you have already in you are engaged with this industry for last 17 years. You
Mhm.
have seen pre India Semiconductor Mission era and post. So,
Mhm.
what changes you are seeing in the with hustle bustle? What kind of work going on around industry?
So India has always been showing a lot of promise to the country, right? I think we've always kept speaking about the growth opportunities within India. I think if you think about it, in the last 5 years or so, the acceleration has really happened because the what used to happen in the past is we used to build whatever we build here in India, or the work that we do here in India was generally to serve the globe. It was very little to serve the local consumption that we had or needed. Now that shift has happened in a very big way. Today, the local demand for products, for technology is so high that it is become imperative for you to actually have the entire ecosystem, like I was mentioning previously, set up in the country. Because today it's no longer just about serving the world, it is about serving yourself in the country to meet the local demands, and in addition to that you also serve for the world, right? So I like the whole concept or the saying that says make in India for India and make in India for the world. I think that is what really is becoming a reality now, and that is why you're seeing the India Semiconductor Mission catching steam. And at the core of all of the technologies, semiconductor is that. And if you're not able to start building your own semiconductor technologies and capabilities within the country, then you will not be self-reliant. I think the intention is
Mhm,
really to become self-reliant faster. So with
mhm.
that drive, with the increase of the local demand, the innovation mindset, all of these things have come together at this point in time, which is why you see an accelerated path towards the semiconductor mission. And semiconductor mission, I think, has been spoken of for many years. It's just now that you're seeing money actually getting pumped in, customers coming in, the real investment happening, groundbreaking happening. So yeah, it is the those three things that I mentioned: the need for self-reliance, innovation mindset, and the local demand.
And this thing will continue. I think
Absolutely.
more
Yeah,
and
I mean,
more cities will come and
the
have.
more technology that each of us keep consuming, there is a need, right?
Mhm.
From a product standpoint, the geopolitical situations, for obviously, it's not the best of places to be in, but then that demands for a lot of technology for you to have, and you need to have a lot of superior technology available with you
Yeah,
at your
obviously.
disposal. So that's another need. India as a country, we are driving towards the EV 30 at 30 mission, which means that more than 30% of the vehicles on the road need to be electric vehicles. So you need to have those capabilities available for you to evolve to start building electric vehicles. You want to reduce the import of vehicles and start manufacturing cars locally. You need to have the technology available here. You want cleaner air. So there is all
Mm.
things that really need to have the right level of technology locally, and yeah, you will see that demand only going up.
Okay. So right now, are you working with any startup?
Yeah, I mean, I do support and help certain startups on the side, mainly to just help with their growth strategies, to figure out how they need to drive the organization to get the right growth, to figure out their go-to-market strategies. So I do those side hustles for sure. Yeah.
So how does NI support semiconductor OEMs in prototyping, validating, and automating their fabrication equipment?
So we partner with semiconductor OEMs not just in chip test, but also in building smarter and more modular fab tools. I think wafer inspection systems, burn-in ovens, handlers, and probe stations. I think these all need embedded control and real-time decision making and tight data logging. So NI's real-time controllers with the modular I/O and open software platform really allows for all these OEMs to prototype quickly, and they can scale efficiently as well. So with software defined control, they can update features in the field, reducing the downtime significantly and ramping up or speeding up innovation. So you can see the semiconductor OEMs, especially with the equipment manufacturers, today are also moving a lot of investments into the country. So you want to build. Otherwise, it was always imported technology. There have been companies in India which have been operating for maybe 12, 13 years without any profit, right?
Mm.
Simply just building up their capabilities. Now is the time when all of these OSATs and fabs are being set up, they will start tasting the business, right? So it has taken that much time for these organizations, and imagine in 12 years that they have done, 12, 13 years that they've been here, there is so much of evolution that's happened on technology that they also need to improve their equipments. And that's where we play a very key role, right? So we allow for that very easily. And also, like I was mentioning, it's software defined control. So you don't have to keep changing hardware. It's easier to change software than hardware.
Mm.
And
Mm. Yes.
and you can also do in-field updates, right? So that makes it a lot more simpler to manage all of these equipments.
Okay. So till now, how much percent of such equipments we used to import?
I mean, I would say 100% of these equipments have been imported always. I don't
Okay.
think so. We, as a country, ever had any company here which made these equipments. Now we have. There are a few that have set up in India. Like I said, they've operated in India for a while, doing R&D to
Okay.
serve the global market. But today, now they have. Now the sales have also begun, and there's a lot of investments already being made.
Okay. So in coming years, this percentage of import will decrease, as we can hope.
Yeah, I mean, if you take a look, the India Semiconductor Mission, though it might seem like a parallel initiative, the intention also is to do Make in India on the ecosystem part as well, right? So,
Yeah.
semiconductor is not just about the fabs and OSATs. You need chemical
Mm.
purification, you need to have clean
Everything.
water. Yeah, so all of that. All of these technologies over a period of time will start getting built up locally here in India, and you will have
The,
companies. That's a huge
in,
opportunity for startups as well. So you'll begin to see a lot of those things happen.
in fact, those inert gases, then a certain level of, the degree of purification is required for inert gases that used during the fabrication. The ambience is filled
Right.
with those gases. So that
Yeah.
kind of companies are also required.
Absolutely.
I'm,
There are very few today in that domain.
mm,
Um, who have started off. They're also doing a lot of work with the academic research institutions like IISc and IITs to figure out how to improve the purification percentages significantly. So there is
Hmm.
a lot of work going on that. There are, maybe about a handful of companies doing this already, but you will see a lot more coming up as the demand keeps
Hmm.
increasing. Those kind of companies will also evolve.
Yes, it's a big spectrum, and we try to cover, and we try to invite guests from every sector. To, I mean, it's not possible for everyone to learn everything. So when a guest like you, a experienced person, come and share their insight and knowledge, it's really beneficial for us. I don't have any much idea about test and measurement equipments, a little bit idea, and now today, after this session, my understanding and clarity, obviously that will increase. So it's really beneficial. We are trying to invite people from from all sectors of this big electronics industry. And so finally we have completed almost all questions. Finally, your suggestion for those young people who want to join any point of electronics industry, and those who want to have their startup, not only just design house, some other ideas might be there, because you are working on across sectors.
Yeah.
You have that idea. If your suggestion about for them.
Yeah, so I would say, I mean, I would go back to what I had mentioned in the past. I would say that please stay curious. I think you should not shy away from doing all the boring parts. And at the same time, do not build products just because they are fancy, or, try and build technology or products which are actually solving customer problems. So understand the customer problems, figure out what the actual issues are, and then build technologies and products around it. It's easier to go and sell some of those technologies when you know that there's a problem statement and you're able to solve for it, than to build a product and then find a market, right? So
Hmm.
that's much harder. So I would say, as an advice to anybody trying to venture into a startup, identify a problem, go dig deep as you can into that, learn it inside out like nobody else's business, and then go and build technology or product or whatever you want to do to solve for that problem, rather than building something first and then identifying a problem.
Okay. Okay. Great. So that was all questions from my side. If you have anything in your mind, specific anything, you can share. If I have not covered anything, please share.
No, I think you've asked me great questions. I feel
Thank
it
you,
was,
sir.
yeah, you've good that you've hosted. I felt it's a great opportunity. Maybe I hope your audience has also got some exposure to test and measurement and learned some things. And I'm glad that you have such a channel which allows
Thank
us
you,
to
sir.
engage with a wide variety of audiences.
Mm.
Giving them different insights and inputs about the whole plethora and spectrum of technology.
Yeah.
So that's exciting. I'm glad to see such a channel that exists.
Thank you, sir. Actually, there was a big disconnect when I was in the working in industry. I felt that. So, I had many questions. There is no one to answer. So from there, we we started to make in VLSI whatever we have worked, so videos, and after some time we got some popularity, and then we thought, let's talk with others, because still a lot of questions are there, no one is giving answer.
Right.
So so for this is almost our 29th episode, and in few months, a lot of huge spectrum we have covered, and in fact, we are with every episode we are also enlightened, and that's a great experience. It's very exciting journey for us also, being on
Right.
this seat of host, talking with some great minds from industry. That's our great experience. Okay, sir. We had all these questions, and you shared your thought, your insight, and it's completely different. I come from VLSI design background, so completely different domain.
Mhm.
Very engaging, encouraging experience for last almost 1 hour I had. Hope you have also enjoyed it. Uh,
Absolutely. It was a pleasure speaking with you, and really thank you for having me on the podcast.
oh, it's a pleasure, sir. Thank you. So, viewers, there was one comment. Rizwan Sheikh has said hello. Hi, Rizwan. I hope you have followed the whole podcast episode. It's really very interesting. If you have missed, it will be in YouTube. Always watch it later. So we will conclude here, sir.
All
Since
right.
we Okay,
Thanks.
so viewers, thank you for staying up to this point with us, and keep watching, keep following Tech Simplified TV, and keep watching the Semiconductor Podcast. We'll be back with another exciting episode. Thank you for um, this episode. Thank you, sir. Thank you,
Thank
viewers. So, viewers, bye for today. Bye, sir.